Okay, now we have to solve this equation, right? Cosine square x plus 2 cosine x plus 1 equals 0 on the interval 0 to pi. So why we specify an interval here is very simple. If you remember how the trigonometric functions are, the trigonometric functions crosses the axis very many times. So they go forever and ever to the left and to the right. So to restrict to 0 to pi is you just take certain interval only. So it's what we are going to do. So only the solutions between 0 and pi. Okay, now this is the situation. You have cosine square of this one, and we are going to do our algebra. So this is the cosine of x squared plus twice the cosine of x plus 1. So what I did, I isolate the cosine, right? And I just going to see this one as a quadratic, you see? This is the same as this one, so it's pretty much like the same as u squared plus 2u plus 1 equals 0. You see that? This is okay. Now, how do you solve this one? Okay, you can factor or you can pretty much try to use the quadratic formula, right? So it's possible to factor this. Let's see. 1, 2 numbers that you multiply, you get the 1. 2, 2 numbers you add, you get the 2. So 1 times 1 is 1, and 1 plus 1 is 2. So this is going to be u plus 1 times u plus 1 equals 0. So these are the factors, correct? And then the only solution we have is u equals negative 1. Because if this is 0, this is 0, u is negative 1. Now, what is the u? Well, I covered with the u the cosine x, so I'm going to put cosine x equals negative 1. And I have to check for what values the cosine is negative 1. Don't forget that you have this formula booklet. So you have this one right here, and here is. Remember, here is your booklet, and here is your table with the, let me just put it right here, with the values, you see? Here, you can see, let me just take this one. Okay, here, now. Okay, you can see here for what angles right here the cosine is negative 1. Here is pi. You see? Between 0 and 2 pi, the only value for which the cosine of the angle is negative 1 is pi. So x equals the r cosine of negative 1, x equals pi. So is what I'm going to write in my paper. So once I see this one, so the cosine of x is negative 1. So the only angle that for which the cosine is negative 1 is pi. And I found this in my tables. So again, resuming this, you're going to receive a trigonometric equation with quadratic terms possibly. Okay, now you check if they are the same. If they are the same, you put them in parentheses. So this is cosine of x squared plus 2 parentheses cosine x plus 1. And then you change the parentheses by other variable, like the regular algebra. I put u. So u squared plus 2u plus 1. Then you see the quadratic. Quadratic. Now, to solve quadratics, you can factor or you can use the quadratic formula. In this case, you can factor. So here are the numbers that make these factors. Then you see that the factor is the same this and this. So just you solve 1 to 0. So this is 0 when the u is negative 1. Now, the u is the cosine. Cosine of x equals negative 1. And the angle has to be pi because cosine of pi is negative 1. Okay? So that's the way we're going to solve these equations. No question? Okay. Let me just go to the next page, page 3, right here. Yep, oh, this one, right here. And we see this one. Negative 2 sine square equals 3 sine x plus 1. Okay. It's pretty much the same strategy. So I have negative 2 sine square x equals 3 sine x plus 1. Okay. And we have to find the solutions between pi over 2 and 3 pi. Okay? It's okay, let's see. This is what we have to solve. Okay, let's see that that clarifies a little bit. What happened? It's blurry. Okay, here it is. Now, oh my gosh. Okay, well, let's see why this is blurry. You see this blurry also?
Yes.
Okay, I don't know what happened. There it is. Okay, so this is what we have to do. So I have here sine squared, so I'm going to do my algebra again. So this is negative 2 parentheses sine x squared. So this is this, you know that, right? Sine squared x is sine of x squared. This is 3 sine x. I'm going to put this in parentheses plus 1. Okay, now what is in parentheses, I'm going to change the variable. I'm going to put 2u squared equals 3u plus 1. Now, I'm going to combine everything in the same side. So I'm going to move this to this side, right? So this is going to be 2u squared plus 3u plus 1 equals 0. What is this? Another quadratic. Okay, now I have to solve this quadratic. So option 1, factoring. Option 2, quadratic formula. What do you want to try? Quadratic formula or factoring? It's pretty much the same thing. So let's do quadratic formula just to recall the thing. So remember, the quadratic formula is a squared, is ax squared plus bx plus c equals 0. So this is the format of the quadratic formula. And then you have to identify the numbers. A equals 2, b equals 3, c equals 1. And then once you identify the numbers, right, you use the quadratic formula, negative b plus minus the square root b squared minus 4ac, right, over 2a. And then the only thing I have to do, this is the x's, right? So I have to identify, so I'm going to put here negative 3, right, plus minus 3 squared minus 4 times 2 times 1 over 2 times 2. So this is my quadratic formula. So this is going to be negative 3 plus minus. This is 9 minus 8. 9 minus 8 is 1. Square root of 1 is 1. So this is going to be negative 3 plus minus 1 divided by 4. So from here, I have that the first x is negative 1/2, and the second x is going to be negative 1. Correct? So those are the two solutions. Why? Because negative 3 plus 1 is negative 2. Negative 2 over 4 is negative 1/2. Negative 1 minus 1 is negative 4. Negative 4 over 4 is negative 1. So those are my things. Now, once I have this one, this is, well, really, I have a trigonometric equation. So I have to recall that, okay, the sine x equals negative 1/2, and also the sine of x is equals negative 1, correct? Okay, now I'm going to check for what values the sign is -1 and -1/2. So what I'm going to do is check my table right here in the pre-calculus formula chart, and I see sine is -1/2, you see here, for -pi/6, and also for 11 pi/6. You see that? -1/2, 7 pi/6, 11 pi/6. Okay, so I'm going to put that one. X equals 7 pi/6, and x equals 11 pi/6, correct? Now, for what values now the sign is -1? Okay, it's here. Here is 0, 1. -1 is 3 pi/2. You see that? Okay, this is x equals 3 pi/2. Okay, so I go to my paper and I see this thing. Now, this is the interval. Are all these roots right here? Yeah, this half is less than this one, and this is less than 3 pi. So these are the solutions of my problems, correct? Okay, so again, the same procedure. You group your quadratic trigonometric equation, you change the variable, then you recognize a quadratic that you solve. Once you solve the quadratic, you remember that the variable you use is sine x or cosine x. Then you make this equation equals, and then using your table from the unit circle, you find for what angles these satisfy the equations, correct? So it's not very difficult. One more example. Right here, this one, okay? This looks a little bit more difficult, right? This is okay. I have cosine square of x equals sine square of x plus 1. Okay. Well, I have to solve this equation, right? It's right here. Okay, now, here is the situation. I have two different functions in the same equation, right? So it's like, okay, this is a u, this is a v, this is a number. So they are not the same. So my first option is change cosine into sine, or sine into cosine. Because if I change this by a sine, I have a quadratic. And if I change this by a cosine, I have cosine squared, another quadratic. So here is the point. How do you change the cosine into the sine and the sine into, or the sine into cosine? It's very simple. You have to remember the trigonometry. You know that sine squared plus cosine squared equals 1. Correct? You can put any angle, so you can put here the x, you can put here the x. Sine squared x plus cosine squared x. So you solve here for one of them. Suppose you want to work with the sine, so you solve cosine squared of x equals 1 minus sine squared of x. So you know this happens. So you can change the cosine by this. So it's what you're going to do right here. So you put here 1 minus sine squared x equals sine squared of x plus 1. Correct? Okie dokie. Now I'm going to group everything together. So I'm going to move these ones to this side. So I'm going to have sine squared of x plus 1 plus sine squared of x. This one, negative, change to positive. And this plus is going to be a minus. And this is going to be 0. Okay, now I'm going to simplify. 1 minus 1, it cancels out. Sine squared plus cosine plus sine squared is 2 sine squared of x equals 0. And then I'm going to do my algebra again. So this is 2 sine of x squared equals 0, right? like this. Okay, now this is a quadratic, so this is the same as 2u squared equals 0. And what is the only solution you have of this algebraic equation? This is very simple. So the only solution you have is u equals 0, correct? There's no way out. 2 times 0 is 0, is the only way. So if you return to your trigonometry, you know that, okay, sine of x equals 0. For what value sine of x equals 0? Okay, let me see. Formula booklet. Okay, right here. So sine is 0 for 0, and it's going to be 0 for 2 pi. You see? 0 to pi. Okay, so those are going to be my solutions. So I'm going to write that. So sine of x is 0 for x equals 0 and for x equals 2 pi. Those are my answers. 0 and 2 pi. Okay. So what you did, well, use trigonometric identities to complete what you need to complete. So remember, all the identities we have here, these ones right here, yeah, all these identities, these identities, these identities. So all of them can be used at your convenience. So you have a toolbox that can help you to change this into something you can solve like this. Identities, okay? So feel free to change any expression but for the result coming from an identity. But remember, yes, the identity has to be chosen wisely, correct? Well, any question here? No? Okay, let me just go to the last page, right? The last page we have right here, this one, right? So you have this problem and this problem. So let's see. Well, pretty much they are the same. Okay, let's see this one. Tangent and cotangent. It's okay. So I have to solve the equation tangent x minus cotangent x, and that has to be 1. So that's my equation to solve, correct? Okay, well, here I have to do something because this and this are different. So I need to change again. I have to change the tangent into cotangent or the cotangent into tangent. So I need to change one of them to make all the same thing. Well, again, remember I told you you can use your identities. So these identities tell you something very important. For instance, here, tangent is the reciprocal of the cotangent, so you can change the tangent by the reciprocal of the cotangent, or you can change the cotangent by the reciprocal of the tangent. You see? You can use any of them. So let me use this one. So I'm going to change the cotangent by a tangent. It's okay. So I have tangent x equals, más bien, cotangent x. This is if cotangent x equals 1 over tangent x. So I'm going to put it here. So I have tangent x minus 1 over tangent x equals 1. Now, like this possibly looks scary. But let me just change the tangent by a u. So I'm going to have u minus 1 over u equals 1. Okay. Remember, when you have fractions and you don't want fractions, it's a good idea if you multiply the equation by the denominator you have. In this case, to cancel this u, you multiply the entire equation by u. So you multiply u times u squared. u over u, 1. 1 times u, u. Okay, now this looks much better than this. And if you put everything together, you're going to see u squared minus u minus 1 equals 0. So this is another quadratic, correct? Okay, now, can you solve this quadratic? U squared minus u, can we factor this thing? Or we have to use the quadratic formula? What do you think? Well, let's see. It says u squared minus u minus 1 equals 0. So if you look for two numbers that you multiply and you get -1, the only options are +1 and -1. But if you add +1 and -1, you don't get -1. So this has to be the quadratic formula. So remember your quadratic formula. It's very simple. You have ax squared plus bx plus c equals 0. So you identify that the a is 1, the b is -1, and the c is -1, correct? So using the quadratic formula, negative of -1, let me just put the quadratic formula, negative b plus minus b squared minus 4ac over 2a. This is my quadratic formula. So I have to put the negative of this number. So I have negative of -1 plus minus -1 squared minus 4 times a, well, that's a 1, times -1, that's the c, over 2 times 1. Okay, now, this is negative times a negative positive 1. This is 1 plus 4. You see? 4 times 1 is 4, negative times a negative positive, 4 plus 1 is 5. So this is a square root of 5 over 2. So my first thing is going to be the x is 1 plus a square root of 5 over 2. And the second root is going to be 1 minus a square root of 5 over 2. Correct? Now, I guess here is going to be a little problem because this is going to be the situation. The x, or really in this case, let me just be consistent. This is the u. This is the u, right? Yeah. Then, versus the u is the tangent, so we have the tangent of x equals 1 plus a square root of 5 over 2. And the tangent of x is also 1 minus a square root of 5 over 2. Correct? Now, I have to solve this one, but these numbers are not in my formula book. Let you check this out. So if you check your formula, you don't see any square root of 5 right there for the tangent. So you see a square root of 3s, but not a square root of 5s. So there is no way out. I have to use a calculator, correct? I have to use a calculator. So if we open the calculator, right here, we open a new document, right? We don't save. And here we put another graph. We put a new document. No, oh, cancel. Let me just add a calculator, right? And then I check that I have radians, you see? It's very important because we have to work in radians. So what I have to use is this. The x is the tangent -1 of 1 plus the square root of 5 over 2. And the x is the tangent -1, 1 minus the square root of 5 over 2. So we have to use the inverse function. So the inverse is tangent -1, or the arctangent is the same. And then you have to take the arctangent of these two numbers. This is what the calculator is going to do for you. Okay, so share the calculator again. Okay, and then I'm going to put here trig, tangent, and then I'm going to write here parentheses 1 plus control square root of 5 over 2. I press Control Enter, and I get 1.01722. And the second value is the same, but with a negative here. So I'm just going to copy. I press Enter, and I can change this by minus, right? I press Control Enter again, and I get negative 0.553574. Okay? So these are the answers I'm going to do, correct? So now, which one of these is the one? Remember that my paper says, let me just show you again. Not this one, is this one right here, right here. So is find the trigonometric equations or solve in 0 to pi. So we have to find the solutions in this interval over the specified interval. In this case, there is no specified interval. So it's open. So 0 to pi is positive, correct? It's a positive interval. So the only number that is going to be in this positive interval is the first one. This is a negative, so this is not a solution. Okay. So again, you have an equation, you use identities to change everything to the same trigonometric function. Use one of the identities you know, in this case, 1 over tangent, changed for cotangent. Then when I have this one, I do my algebra. Remember, this is a number. I mask this tangent u by u in order to make my life easier. So I have this algebraic equation. Then I cancel fractions, I manipulate to get a quadratic. I solve my quadratic. Then I return back to my tangent and I find the angle for which this tangent is this value. Okay? Some cases we have to use a calculator. Some cases we have to use our table in the formula booklet. Okay, any question? You think you can go by your own for the homework? It's pretty much the same thing.